Welcome to Homework Lib.
Hi. So in this problem, what we have is that we added 1.49 milliliters of 0.410 molar solution of HI with 9.66 milliliters of a 0.570 molar solution of sodium hydroxide. So the first thing that we need to do is know how much actually reacted. In order to do it, let's put down our neutralization reaction. We can see clearly that we have a one-to-one correspondence, generating NaI plus water. Of course, all of this is going to happen actually as ions in solution, but in chemistry, most of the times we just put it like this to simplify things a lot for us. So now, I need to know the amount of HI that I added to the solution. In order to do it, remember that molarity is equal to amount of mole divided by volume. So amount of mole would be molarity times volume. Would be molarity times volume, as I mentioned, so 0.410 molar times my volume, written in liters, so 1.49 times 10 to the minus 3 liters. And I'm going to do exactly the same with NaOH, and B equal to 0.570 molar times 9.66 times 10 to the minus 3 liters. And the results are respectively 6.109 times 10 to the minus 4 mole and 5.5062 times 10 to the minus 3 mole. So the limiting reagent, it is going to be clearly HI. And since we have a one-to-one relationship in between HI and sodium hydroxide, we know that the amount reacted is 6.109 times 10 to the minus 4 mole. So the heat coming from this reaction corresponds to that amount of mole. Okay? Now, after we have done this, we can go ahead and see the data for the calorimeter. So that is like part 2 of this solution. We know that the change of temperature, it is going to be equal to 4.01 degrees Celsius. We are told that the density of the solution can be assumed to be 1 gram per milliliter. We know that the total volume of solution is going to be the sum of the solutions that we added. That is going to be 11.15 whoops 0.15 milliliters. So we can now directly the mass. Recall that density is equal to mass divided by volume. So mass is equal density times volume. The density is equal to 1, and we're going to get 115 grams of solution. Perfect. Now, the change of delta T is going to be positive. That means that the reaction was exothermic. We need to take that into account because we are going to get a value for delta H, and that value for delta H needs to be negative, right? For an endothermic reaction. Sorry, for an exothermic reaction. So let's write this down. Delta T positive. That means that we have an exothermic reaction, which means that the delta H needs to be negative. Okay. Another way to do it is remember that the heat from the reaction, it is going to be equal to minus the heat absorbed by the calorimeter. So heat of calorimeter. Both of the ways are equivalent. Depending on the professor, they prefer one or the other, but the whole idea is the same thing. So let's calculate the heat of the calorimeter that we have. We know the value for delta T. We know the amount of mass. So mc delta T, in this case, is 11.15 grams times C. The value for C is equal to 4.18 joules per gram degree Celsius. So 4.18 joules per gram per degree Celsius. And we know that delta T was 4.01 degrees Celsius. Let's put everything in parentheses and cancel up the units where we can. The result for Q of the calorimeter is equal to 186.89 joules. Perfect. So that means using this relationship or just changing the value, the delta H for the reaction, the change of enthalpy, it is going to be equal to minus that result. And we need to divide it by the amount of mole of reaction that we have. So this is minus 186.89 joules divided by the amount of mole that we had of reaction. We said that is 6.109 times 10 to the minus 4. 6.109 times 10 to the minus 4 mole. This gives us the final result for delta H of 305,932 kilojoules per mole. Sorry, joules per mole. I went a little bit ahead of myself. Joules per mole. Here I'm not going to put all of the decimal points because it doesn't make sense, since the result is asked in kilojoules per mole. So delta H is going to be 305.932 kilojoules per mole. And that would be all. Thank you very much.